look at this equation, 11 plus 8 plus 9 plus 7. If you try to add these up from left to right, your brain has to hold on to a constantly changing total while processing the next number. By the time you reach the 3, your short-term memory is already starting to max out. Sequential addition is slow because it forces the brain to juggle too many variables at once. But numbers don't have to stay in the order they were written. Scan the entire string for compatible pairs, numbers that add up to exactly 10, 8 and 2, 7 and 3, 11 and 9. Tens are the anchors of mental calculation. By restructuring the problem to find them, you offload the heavy lifting from your memory onto the logic of the numbers themselves. Many problems won't offer a perfect pair by default. Take 116 plus 118. When a clean 10 isn't there, you can create one by decomposing a number. If we take 4 from the 8 and move it to the 116, we create a round 120. That leaves us with a much simpler task, 120 plus 114. This strategy is known as compensation. You are subtracting a small amount from one number to round up the other, making the total easier to track. Jumping around an equation to build these tens carries a risk. It is easy to double count or skip a remainder. To stay accurate, you must cross out each number as soon as it's grouped. Transforming numbers into tens turns an abstract memory exercise into a concrete process of visual grouping. Subtraction creates a different challenge. If you're solving 100 minus 68, it's tempting to try making both columns add up to 10, seeing a 6 and picking 4, then seeing an 8 and picking 2. But 42 is the wrong answer. The correct pattern for complements of 100 is the 9 and 10 rule. The tens digit must add up to 9, and the ones digit must add up to 10. 6 plus 3 is 9, 8 plus 2 is 10. The distance is 32. This rule accounts for the 10 that is carried over from the ones column during a standard subtraction. Use that rule now. What is the complement of 46? 4 plus 5 is 9, 6 plus 4 is 10. The answer is 54. Applying the 9 and 10 rule turns a subtraction problem into instant pattern recognition. Multiplication strings like 5 times 7 times 5 times 8 times 2 times 2 are almost impossible to track if you calculate them in the order they appear. Because of the associative property, you can rearrange these factors to suit your needs. You can hunt specifically for 2s and 5s to build quick 10s. Rearranging the numbers visually simplifies the entire problem into 10 times 10 times 56. The final result is 5600. When the factors you need aren't visible, you have to break numbers apart with a specific goal in mind. If you take 24 times 25 and split 24 into 12 times 2, you haven't made the math any easier. Look at the 25. It needs a 4 to become 100. By decomposing 24 into 6 times 4, you compare that 4 with the 25. 6 times 100 gives you 600. Speed comes from manipulating these factors to create zeros before the actual multiplication begins. Imagine you're at a store and need to quickly total this list of items to see if you have enough cash. Scanning the board for compatible prices allows you to group the 2s and 8s into round numbers. Within seconds, you have a precise total. To find your change from a $100 bill, apply the 9 and 10 rule to that total. The correct amount appears instantly. Use this cheat sheet to help you look for these patterns in your next calculation. Mental math is a game of pattern recognition. By manipulating numbers into tens and hundreds, you replace the mechanical grind of calculation with the more efficient work of strategy.